Hi, my name is Samir Desai, and in this video, I'm going to teach you how to identify an acid or a base as strong, weak, or inert.
In previous videos, we discussed what the acid dissociation constant and the base dissociation constant mean. Recall that these dissociation constants are a quantitative measure of the strength of an acid or base. The larger the value, the stronger and more reactive the molecule. We can use these values to gauge if an acid or base will be strong, weak, or inert. An acid is considered strong if the acid dissociation constant, Ka, is greater than 1. Since the base dissociation constant, Kb, follows the same trend, a base where the Kb is greater than 1 will also be considered strong. And if the Ka or Kb are less than 1, but greater than 1 times 10 to the negative 14th, it would be weak. These ranges aren't arbitrary though. Strong acids, like hydronium, have a Ka equal to 1, and strong bases, like hydroxide, have a Kb equal to 1. So any dissociation constant less than that is not considered strong. That said, 1 times 10 to the negative 14th is the value of Kw, and a Ka or Kb less than that would not be reactive. That brings us to the last categorization. If the Ka or Kb is less than 1 times 10 to the negative 14th, then that acid or base is said to be inert. Let's apply this information to identify which of these categories a molecule falls under. In this question, we're given 6 bases, along with their base dissociation constants, and we have to identify the base as strong, weak, or inert. Let's bring back the chart from the previous slide to help us with this. We'll run through each question and determine the magnitude of the Kb so we can identify the strength of the bases. Starting with A, we have a lithium hydroxide with a Kb of 1 times 10 squared. This value is larger than 1, so it must be a strong base. The chloride in B has a base dissociation constant of 7.7 times 10 to the negative 22nd. This value is very small, even smaller than 1 times 10 to the negative 14th, so this must be an inert molecule. Moving on to C, NH3, or ammonia, has a Kb of 1.8 times 10 to the negative 5th. This is larger than Kw, but not larger than 1, so this is a weak base. You may see potassium hydroxide in D and immediately know it's one of the strong bases based off prior knowledge, but let's take a look at this quantitatively. The Kb is certainly larger than 1, and this is confirmation that it is a strong base. The molecule in E is aniline. A Kb of 4.3 times 10 to the negative 10th is greater than the Kw, but less than 1, so this is a weak base. Lastly, we have hypochlorite in F. With a Kb of 3.2 times 10 to the negative 7th, this also falls in between the Kw constant and 1. Therefore, hypochlorite is a weak base. By this point, you should feel comfortable with the acid and base dissociation constants, be familiar with the relationship and trends between these two values, and be able to identify the strength and reactivity of an acid or base when given the dissociation constant. Make sure to follow up this lesson with some practice to solidify the concepts.